Okay, so 6.5 is factoring binomials. So when we're looking at binomials, it means it's two terms. And so first, as always, you check for descending order. Then you factor out a GCF if possible, right? Then what you do is you check for difference of two squares. So the difference of two squares means that you have a squared minus b squared. So the first term is some value to the second power, and then the other term would be some value to the second power, essentially. So basically, does A and C, can you multiply them? A and B, can you basically multiply them by the same two factors? So can you split them to be the same two factors? So x squared is an x and an x. 9 is a 3 and a 3. So it's a difference. So this would be the difference of two squares, right? Difference, subtract, of two squares, two things multiplying to itself. Oh, wow. So when we factor it, factoring the difference of two squares is always the same process. A minus B, A plus B. Once you know the two factors, the x squared is x and x. The 9 is a 3 and a 3. One's a plus, one's a minus. And that's it. All right, number 2, 2x squared minus 8. So it's in descending order. Factor out a GCF. There is a GCF here. They both contain a 2. So I'm going to factor out a 2. So that leaves x squared minus a 4. So then I check to see if I can still factor. So I'm looking at x squared minus 4. I check to see if that's the difference of two squares. It is, because x squared is x and x. 4 is 2 and a 2. So I can factor this further. So two sets of parentheses, x and x, 2 and 2, one's plus, one's minus. That's it. All right. Next one, 3y squared minus 18. So it's in descending order. Factoring out a greatest common factor would be a 3. So y squared minus 18 divided by 3 is 6. So y squared minus 6. So then we check for the difference of two squares. So y squared is y and y. 6 is 2 times 3, 1 times 6. So let's make sure we pay attention. You cannot factor y squared minus 6. It is not the difference of two squares. 6 is not a square. You add 3 and 3 to create 6. You don't multiply 3 and 3 to create 6. So this problem would be finished because we cannot factor it anymore. Okay? So, makes sense? All right, let's do some more. All right, so let's look at this. 4y squared minus 25. So we go through our checklist. Descending order, yes. Factoring out a greatest common factor, there isn't one. Next, is it the difference of two squares? It is a difference. Let's see if they're both squares. So 4y squared is a 2y times a 2y. 25 is a 5 and a 5. Yep. So 2y, 5, 2y, 5. One's a plus, one's a minus. And I'm finished. So that's factoring binomials. Next, 9x squared minus 81. So we're looking at descending order, yes. Factoring out a greatest common factor. There is a GCF of a 9. So when I factor that out, I'm left with x squared minus 9. So then I can factor that further. X squared minus 9 would be xx, 3, 3, one's plus, one's minus. And we're finished. Y squared plus 4. So descending order is already in it. Factoring out a greatest common factor, there is no greatest common factor. And then difference of two squares. It's not a difference. So this problem cannot factor. So this is considered prime or not factorable. All right. So a lot of students think, oh, well, it'd be y times 2 times y plus 2. Really? Is it? If we multiply that, y squared plus 2y plus 2y plus 4. Because you should have already seen that when you have binomial squared, it's a perfect square trinomial. So you can't have the same signs and create a binomial, right? So in order for it to be a binomial, it's two terms. And in order for it to be the difference of two squares, it has to be a subtract. And then it has to only be two terms present. So in order for us to not have a trinomial, the middle terms factor must cancel out. So plus AB minus AB cancels out, which is how you end up with just a squared minus b squared. So in order for it to be the difference of two squares when it factors, it has to be different signs. Okay, so that's factoring binomial.